All right, so we're going to briefly look over Chapter 7 and talk about kind of our general patterns or functions and logarithms. So we have these patterns within our XY tables for the four types of functions we looked at. Linear is the easiest. You just add to x would be an add to y. Quadratic is the trickiest, where you have a constant second order difference. So if you take the difference of the differences on the y side of the table, you would get the same value. Power is you multiply the x, you multiply the y, and then exponentials you add on the x, which leads to a multiplication on the y. And so we can use that if we're given our values, our functions at the bottom here and some points, we can set up some equations to solve. So I have an exponential, which our general form is ab to the x power, and that it passes through these 2 points. I just use values for x and for y and plug them in. So y is 6.5, x is 1, those go in there, I get one equation, and then I can use the other points, that's my second equation, and then I can solve for a, so I just take this, divide by b, and then I'm going to drop that in here, I'm going to substitute, and I would get some value for b, and from there I could solve for b, and then use that value to solve for a, and then I'd be done. For quadratic is the hardest. I would have to use ax squared plus bx plus c, and I'd need 3 equations to solve that because I got to figure out a, b, and c. So there's one using that first point, 1 and 6. There's my second one using the point 3 and 4, and then the third one using 5 and 18. And then I would have to use a system of equations, whether with elimination or substitution, or if we know some linear algebra, we could do it that way to solve those. And then the last one is where my power function, where x is the base, and again I use my 2 points, I set them up, there's 1, there's 2, and then I would do some substitution and solving, in this case probably for a, to be able to get my values. And so then moving into our logarithms, we have our properties of logarithms, and we have equations that we can solve with logarithms. So for the first one, my logarithm here says that this is the power. 4 to the 1/2 power should equal 2x minus 3. 4 to the 1/2 power is the square root of 4, which is 2, and then I could solve that from there. For the next one, I want to expand it. I'm going to bring that down in front, and then where I have division within my logarithm, that becomes subtraction, and multiplication becomes addition. So it works just the same way that your properties, your values do in terms of exponents. And then I expand the 2x into natural log of 2 plus natural log of x minus natural log of y. All that is multiplied by 2. To go the other way, I just bring these back together. I'd bring my powers up until I get log of a squared minus log base 3 of b to the third plus log base 3 of c. And then I bring them together with addition becomes multiplication, and then subtraction becomes division. The last one, I get some exponential on one side and a number on the other, so I just divide by 7. And then I got to get the x out of here. So to undo an exponential, I need a logarithm. In this case, the natural logarithm because it's base e. So I bring that 4x down in front after I take the natural log of both sides. ln of e is just 1, so it's 4x is ln 9, divide by 4, and that's your final solution.